Welcome to the presentation for CMP7001 Advanced Programming. This work showcases the ETD technology system developed as a console-based Java application. The prototype simulates real-world repair center operations using Java object-oriented design patterns and error handling. The walkthrough demonstrates functionality, design structure, and key learning outcome from the development process. And coming to introduction, the goal was to replace ETD technology's spreadsheet system with a modular software solution. A console-based application was chosen, supporting administrator, technicians, and customers. Each user accessed tailored functionality through menu-driven flow. Java was used for its operation, its strength, and various design patterns were employed to structure the logic cleanly and maintainably. And coming to class diagram overview, the class diagram reflects a structured architecture following the single responsibility principle. The user superclass is extended by administrator, technician, and customer. Classes like repair job, supplier represent key domain entities. Service and menu handler separate business logic from user interaction, resulting in modular, testable component that closely reflect real-world system behavior. And object-oriented principle used. Object-oriented principle were embedded through the system. Inheritance enabled role-based feature abstraction, hide internal logic through well-defined interfaces, encapsulation secure data within classes, while reusability was promoted through services. These principles improved code clarity and helped manage complexity, making it easier to extend or debug the system at any stage. A polymorphism played a key role in ensuring flexibility. A common user interface is used to invoke different role-specific logic dynamically. A strategy pattern also demonstrates polymorphism by letting the system switch between cost calculation algorithms. This approach supports cleaner logic routing and simplified how functionality was delivered across different user roles. Rational design pattern. The factory pattern was used to create different user type like administrator or customer. Instead of manually and station subclasses, the factory turned the appropriate object-oriented, object-based role on input. The abstraction, the creation logic avoid code duplication and makes the system more reliable, maintainable, especially if new user type are added in future. Structural design pattern. The observer pattern was used to notify customer when their equipment is ready. Observers are registered to listen for job status update. When the state changes, all subscriber customer are notified. That separates notification logic from core processing, reducing coupling and allowing flexibility in how future alerts or communication feature are delivered. Behavioral design pattern. That strategy pattern was applied to calculate repair job cost. Administrator can choose between a simple flat rate model or an advanced model that includes tax and overheads. The behavior is encapsulated in interchangeable strategy classes. The design adheres to the open close principle, allowing logic changes without modifying existing code structure. And coming to exception handling, robust, ap- robust exception handling was implemented using both API level and custom exceptions. Scenarios like invalid user input or missing job IDs trigger specific exception with meaningful message. Clause like no job not found exception and invalid input exception enhance enhance error. This makes the system more reliable and help guide user when error occur. Walk through the functionality. Application was tested through a complete interactive walkthrough. User could register, log in, assign jobs, and update statuses. Test scenario covered role-based flows, invalid data entry, duplicate processing. Some early bugs were resolved, including scanner input crashes and incorrect job allocation logic. The final version was verified manually. Reflection of learning. The project reinforced key programming principles beyond theory. Implementation, real design pattern in Java clarified their purpose. Debugging scanner error and organizing service were valuable learning moments. Building a working prototype improved confidence in system design, while structuring services and handling exception taught practical lessons in writing reliable, extensible code. Coming to last slide, conclusion. The EOD technology prototype demonstrated a functional role-based repair system built on strong software principles. The project addressed the real business needs, used appropriate design pattern, and was coded with clarity and structure. Thank you.